Hey guys, and welcome to this video on changes in state, which is P1.2. So density tells you how much mass there is in a certain volume, and it's why some substances which are the same volume have different masses. It's because they have different densities. So to calculate it, you do mass divided by volume, and the units are kilograms divided by meters cubed. So that's another way you can remember the equation. And solids are more dense than liquids and gases because if you think about how the particles are arranged, there's more particles in a certain area of a solid. So energy and temperature are not the same thing. That's the first thing you have to remember, because temperature is how hot or cold something is. And most people use degrees Celsius, but scientists also use Kelvin. And these units go up in the same amounts, just 0 Kelvin is absolute zero. And when you heat, for example, water, this is anything, the particles start vibrating faster, but the particles themselves do not get hotter. What gets hotter is the substance. And energy tells you how fast the particles are vibrating. And temperature tells you the average energy of a particle. And then if you heat something, there are three things it can do. It can change the energy stored. So like the amount of energy, it will increase the amount of energy, which then changes the temperature. It can produce a change of state, or it can make a chemical reaction occur, for example, when burning wood. And then you have specific heat capacity, which is the amount of energy needed to raise the temperature of 1 kilograms of a substance by 1 Kelvin. So the way you can figure it out is that change in thermal energy is mass times specific heat capacity times change in temperature. And you can see specific heat capacity is in joules over kilograms times Celsius. So that's another way you can remember the formula, and that's with if you're figuring out the specific heat capacity. And it tells you how resistant a material is to a change in temperature. So if it's the higher it is, the more resistant the material is to changes in temperature. So water is very resistant, so it's used in central heating systems, as it doesn't lose its heat for a long time. And it's also why the ocean doesn't freeze, even when there are freezing temperatures, because the ocean doesn't change temperature as easily as the air. And then saucepans are made of metals with low specific heat capacities, so that they warm up faster. However, you do have to consider other stuff. For example, you don't want a metal that costs a lot of money, for example, gold. And then there's specific latent heat, which is similar to specific heat capacity, but not the same. So the basis with specific latent heat is the fact that to cause a change in state, you must heat or cool a substance. So, for example, when water in the ocean evaporates to form water vapor, energy transfers from the surroundings to the water, and then the opposite happens when water vapor condenses. So basically, when you have a change of state, there's no temperature change while there's a change of state, because the energy is being used to break the bonds of attractiveness rather than increasing or decreasing the temperature. So specific latent heat of fusion is the amount of energy transferred when 1 kilograms of a substance goes between solid and liquid. It doesn't matter which way, as it should be the same, except one will be energy being released and one will be energy taken in. And then specific latent heat of vaporization is the same, except it's between liquid and gas. And the formula, pretty obvious. The amount of energy for this change in state is the mass times the specific latent heat. So one thing you must remember to not confuse these two terms up. that specific heat capacity is change in temperature, but specific latent heat is change in state. Anyway, guys, thanks for watching. Bye.